Hi, myself Dr. Prashant Kumar Baltu, Professor, Mechanical Engineering Department, GIS College of Engineering, Kollam. Subject topics: Advanced Welding Technology. Code is ME703A. Today's lecture number 9, Solid State Welding. Welding processes can be classified into two major groups. One is pressure welding and another is non-pressure welding. Pressure welding is basically solid state welding, and non-pressure welding, that is called fusion welding. Majority of the welding is fusion welding. Around 90% welding is fusion welding, and fusion welding coalescence is accomplished by melting the two parts to be joined. In some cases, adding filler metal to the joint. Examples: arc welding, resistance spot welding, oxy-fuel gas welding, and pressure welding, that is also called solid state welding, where heat and or pressure are used to achieve coalescence, but no melting of base metal occurs and no filler metal is added. Example: forge welding, diffusion welding, friction welding, ultrasonic welding, etc. So classification welding is again discussed. That is friction welding, one is, and what I told already, that friction welding, 90% welding is friction welding. One of the major welding processes in friction welding is arc welding. In arc welding, sealed metal arc welding, gas metal arc welding, tungsten inert gas welding, submerged arc welding, flux core arc welding, electroslag welding, etc. Gas welding, here acetylene welding, oxyacetylene welding, oxyhydrogen welding, pressure gas welding. In resistance welding, RSW, RSEW, EW, PEW, FW, etc. Intense energy beam welding, that is plasma arc welding, electron beam welding, laser beam welding. And solid state welding, that is we have discussed, that is pressure welding. In that particular, there are several welding processes are there. Cold welding, roll welding, pressure welding, diffusion welding, friction welding, and friction welding. Solid state welding is a group of welding processes that produce sound joints and temperature essentially below the melting point of the parent materials without bulk melting of parent materials. Solid state welding processes have been widely applied in automobile, aircraft, and aerospace industries because of their enormous advantages associated with solid state features. Solid state welding is a welding process in which two workpieces are joined under a pressure, providing an intimate contact between them and at a temperature essentially below the melting point of the parent materials. Bonding of the materials is a result of diffusion of their interface atoms. Solid state welding processes are usually free of various solidification Defects such as gas porosity, hot cracking, non-metallic inclusions, which may otherwise be present during fusion welding processes. No filler materials, fluxes, or sealing gases is required during solid-state welding process. The metal being joined can have mechanical properties similar to or even better than that of their parent metals due to their absence of defects and heat affected zone in most of these processes. In addition, solid-state welding processes are also very suitable for joining dissimilar materials as their chemical compatibility, thermal expansion, and conductivity are no longer important problems. Solid-state welding, alternatively called solid-state bonding, covers a wide spectrum of processes, including cold welding, forge welding, artesonic welding, friction stir welding, resistance welding, diffusion bonding, and explosive welding. Solid-state welding bonding is achieved through deformation and diffusion at certain pressures and temperatures by using mechanical, electrical, or thermal energy. Unlike various fusion welding processes, which are well known, appointed by industrial engineers, solid-state welding plays an important role in special bonding of dissimilar metal joint. There are types of solid-state welding. One is forge welding, cold welding, friction stir welding, explosive welding, diffusion welding, artesonic welding. Advantages of solid-state welding. Weld bonding is free from microstructural defects. Mechanical properties of the weld are similar to those of the parent metals. Consumer materials are not required, that is, filler materials, fluxes, sealing gases, etc. These are not required. Dissimilar metals may be joined, that is, steel, copper, aluminum, cobalt, etc. Advantage of solid-state welding. Weld bonding is free from microstructure, defects, pores, non-metallic inclusions, segregation of alloy elements. Mechanical properties of the weld are similar to those of the parent metals. Consumable materials, that is filler material, fluxes, sealing gases are not required. Dissimilar metals may be joined, steel, aluminum alloy, steel, copper alloy, etc. Advantage of solid-state welding. Solid-state welding can be easily automated. This produces high staying joint without applying external heat. They use to weld both similar and dissimilar material. Provides good surface finish. They does not use any filler metals or flux as used in the arc welding. Mostly these processes do not affect properties of parent materials. It eliminates liquid phases. It can apply at different temperatures and under different stages. Weld is free from microstructural defects. Disadvantage of solid-state welding. Thorough surface preparation is required, that is degradation, oxide removal, blasting, and sanding. High equipment cost or setup cost. Joint design is limited. Complicated and special fixtures are required for different processes. Mostly these processes can't be used for mass production due to slow welding speed. Application of solid-state welding, bonding of stainless steel liners in aluminum fry pans, aluminum cladding welded to uranium fuel rods, ultrasonic and thermo-compression bonding in microelectronics industry. Friction welding is in aerospace and automotive applications. Intake, intake and exhaust automatic valves. Forge welding. Forge welding is a solid-state welding process in which low-carbon steel parts are heated to about 1000 degrees centigrade and then forged, hammered. Uses forge welding is used in general blacksmith shops and for manufacturing metal parts, pieces, and welded tubes. Advantage of forge welding: good quality welding is obtained. Parts of intricate shape can be welded easily. No filler material is required. Disadvantages of forge welding: only low carbon steel may be welded. High level of operating skill is required. Slow welding process. Weld may be contaminated by the coke used in heating furnace. Cold welding. Welding is a solid state welding process in which two workpieces are joined together at room temperature and under a pressure, causing a substantial deformation of the weld parts and providing an intimate contact between the welded surfaces. As a result of the deformation, the oxide films covering the welded parts breaks up and clean metal surfaces reveal. Intimate contact between these pure surfaces provides a strong and defectless bonding. Material used in cold welding: aluminum alloy, copper alloy, low carbon steel, nickel alloy, and other ductile metals may be welded by cold welding. Application of cold welding. Cold welding is widely used for manufacturing bimetal steel, aluminum alloy strips. Perhaps the greatest use of cold pressure welding has been for joining of wire, foil to wire to bimetal, and sealing of heat-sensitive containers, such as those containing explosives, detonators, for examples. Rod coils are part welded to permit continuity in post-weld drawing to smaller diameter. That means in weld drawing to lower diameter. Friction welding. Friction welding is a solid-state welding process in which two cylindrical parts are brought in contact by a friction pressure when one of them rotates. Friction between the parts results in hitting their ends. Force pressure is then applied to the pieces, providing formation of the joint. Friction welding. This is a friction welding. Rotating chuck on side. Left side is rotating chuck. Right side is non-rotating chuck. Movable axially. The left side is rotating, and this second figure says the left side is rotating and right side is part connected, brought to the contact to develop a friction. When friction is developed, heat is generated, and third figure is the rotation stopped, force is applied from the both side or maybe from one side, and pressure is applied, so welding joint is performed. The fourth one is welding joint is performed, that is, and figure 4 is that some parts are there, they has to be removed. Application and limitations of friction welding. Shaft or tubular parts, industries, automotive, aircraft, farm equipment, petroleum and natural gas. Limitations: at least one of the parts must be rotational, flash must usually be removed, offsetting reduces the part's length, which must be taken into consideration in product design. Material used in friction welding: carbon steel, alloy steel, tool and die steels, stainless steel, aluminum alloy, copper alloy, magnesium alloy, nickel alloy, titanium alloy can be joined by friction welding. Friction steel welding is a new invention. The invention of friction steel welding has been considered as one of the most revolutionary steps in welding technology. Friction stir welding is a solid-state welding joining process. The metal is not melted. That use that uses a third body tool to join two facing surfaces. Heat is generated between the tool and material. And this figure, A, B, C, D, A is unaffected zone where the basic materials are there. There is no affected. B is a heat affected zone that is has. C is a thermomechanically affected, and D is a nugget where welding zone was performed, and the tool is rotating parts, and the pressure is applied, tool is rotated, and one probe is there through which friction is done. Friction stir welding is a new solid-state welding joining process. There is a cylindrical soldered tool along with a profiled probe is rotated and fed into at a constant traverse rate into the joint. Frictional heat generated between the wear resistance welding tool and the workpieces, along with mechanical mixing heat, causes the steel material into a soften without bleaching. Friction steel welding advantages: low distortion and sinkage, no arc, no porosity, can operate in all conditions, energy efficient, good mechanical properties and fatigue, tensile and bend test, low environmental impact. Friction steel welding disadvantages: workpiece must be rigidly clamped, keyhole at the end of each weld, cannot make joints which require metal depositions. Initial cost of the machine is very high compared to fusion welding fusion welding machine. Application of friction stir welding: shipbuilding and marine industries, aerospace industry, railway and land transport. Explosive welding. Explosive welding is a solid-state welding process in which welded parts, these plates, are metallurgical bonded as a result of oblique impact pressure exerted on them by a controlled detonation of an explosive charges. Explosive welding, commonly used to bond two dissimilar metals, in particular to clad one metal on top of the base metal over large areas. Figure explosive welding, figure 1, set up in the parallel configurations during the detonation of the explosive charges. Left side is materials to bring the charging. Second one is charging. The metal and two plates are joined together. Explosive welding. Dissimilar metals may be joined by explosive welding. Copper to steel, nickel to steel, aluminum to steel, tungsten to steel, titanium to steel, copper to aluminum, etc. Advantage of explosive welding: large surface may be welded, low cost and simple process. Surface preparation is not required. Disadvantage of explosive welding: brittle materials, low ductility, and low impact toughness cannot be processed. Thickness of flare plate is limited. Safety and security aspect of storage and using explosive. Diffusion welding. Diffusion welding is a solid state welding process in which pressure applied to two workpieces with carefully cleaned surfaces and at an elevated temperature below the melting point of the metals. Bonding of the metals is a result of mutual diffusion of their interface atoms. Diffusion welding, in order to keep the bonded surfaces clean from oxides and other air contaminations, the process is often conducted in vacuum. No appreciable deformation of the work pieces occur in diffusion welding. Diffusion welding is often referred more commonly as solid state welding. Diffusion is able to bond dissimilar metals which are difficult to weld by other welding processes. Steel to tungsten, steel to niobium, stainless steel to titanium, gold to copper, etc. Advantages of diffusion welding: dissimilar material may be joined or welded. High quality welding is obtained. No limitations in thickness of the work pieces. Disadvantage of diffusion welding: time consuming process with low productivity. Very thorough surface preparation is required as compared to welding process. Relatively high initial investment in equipment. Ultrasonic welding. Ultrasonic welding is a solid state welding process in which two pieces are bonded as a result of pressure exerted to the welded parts combined with application of high frequency acoustic vibration, that is ultrasonic vibration, ultrasonic sound. Ultrasonic vibration causes friction between the parts, which results in a closer contact between the two surfaces with simultaneous local heating of the contact area. Interatomic bonds formed under these conditions, providing strong joint. Ultrasonic welding, the figures of ultrasonic welding. This one is general setup for lap joints. This is a sonotone tip, anvil, and over the anvil, lap joint is there. Parts to be welded. And the ultrasonic transducers is there, and sonotone tips. So two transducers, the sonotone tips is vibrated, and from the top, pressure is applied. This in the right figures, the workpieces. The top of the invalid, vibrated motion is there to the sonotone tip, and down on pressure is there. So through pressure and the sonotone tips vibration, it is plastic steps and then it is joined together. Advantages of ultrasonic welding: dissimilar metal can be joined. Very low deformation of the work pieces, surfaces. High quality weld is obtained. The process may be integrated into automated production lines. Moderate separator skill or moderate operator skill level is enough. Disadvantage of ultrasonic welding: workpiece may bond to the anvil. Only small and thin parts can be welded. Ultrasonic welding applications: wear terminations and splicing in electrical and electronic industry. Eliminates need for soldering. Assembly of aluminum sheets, metals, panels. Welding of tubes to seat in solar panels. assembly of small parts in automotive industry. Thank you.